Alright, so welcome to the next lesson in their series. This one is on solving cubics. Now cubics is any polynomial that has the highest power of a 3, or cubed, just like quadratics had the highest power of a 2 or squared. So cubics' highest power is a 3. Now, when we talk about solving them, we should all remember that solving means we are finding the x-intercepts. Alright, so keep in mind your processes that you need to do that, namely the biggest one is factorizing. All right, so this set is going to be all about factorizing cubics. So previously, the last set looked at remainder theorem and remainder theorem and factor theorem, which gave you two ways to find factors of higher powered polynomials. So we can use these throughout this set. All right. So the first thing to remember is that in most straightforward form, a cubic can be factored into 3 brackets, which could look like this. All right. And being that we're finding x-intercepts, the y value would be 0. So what you were looking at doing is using the null factor law to find out what the x values are for each of those factors to produce an answer of 0. So your 3 solutions would be 2, -2, and +1, which could be simplified down to those. All right, so null factor law applies at every point when you are finding x-intercepts and factorizing. All right, so then we'll quickly whip through a few other examples before getting to the meaty ones. So here's another example, which was 2x cubed minus x squared minus x equals 0. So to factorize this, you might notice that every term has a x in it, so we could factorize an x out first, which would leave us with this quadratic. Now I'm going to use the cross method to find out the factors of this quadratic here. So a times c is -2, here's -1. So factors of -2 that add to make 1. You could have 2 and 1. You could have -2 and +1. That's right, that will work, -2 and +1. Then I need to remember to divide by the coefficient, so it's 2. Cross out those ones that didn't work. So my 2 solutions are -1 and a half. So I've got brackets looking like this. So I've got x -1, x plus a half, and the third one, which I already knew, was just straight x. So now my solutions are 1, minus a half, and 0. All right, given that that equals 0, this equals 0, or that equals 0. All right, so in this example, we've got quite a long polynomial, and I'm going to use the factor theorem and remainder theorems to find some answers. So in my calculator, I will define it as px, and then I'll just plug in values just to see whether the answer is 0 or not. So my calculator tells me that the answer for this one is not 0. My calculator tells me that the answer for -1 is also not 0. I'm going to try 2, which has a remainder of 0. Nice work. Okay, so this means that x -2 is one of my factors. So I'm going to have to do it by long division now. So x cubed minus 4x squared minus 11x plus 30 divided by x -2. So it's going to give me x squared, x cubed minus 2x squared there. Subtract that out. That gives me -2x squared. Drop down the next term. Divide this one through, which gives me -2x. Multiply it back down. Multiply that one, which gives me 4x. Subtract those, which gives me -15x. Divide that by x. Drop down the constant. Multiply the 15 back down. -30. Subtract that out. Oop. That should have been plus originally, and then I subtract it. That will turn into a plus. That'll turn into a minus. And there's my remainder of 0. But most importantly, there is my quotient, which I do need. So I've got x squared minus 2x minus 15. I can factorize this by sight. So factors of 15 that add to make minus 2 are in fact 5 and 3. That needs to be a negative to produce negative 2. So there's an x there. There's an x there. And my third factor just drops to the front here, x minus 2. All right, so this has been factorized using a combination of remainder theorem and long division, and then factorizing the resultant quadratic by sight. To do this on your Casio, you're just going to need to use the solve function, enter your polynomial equals 0. It automatically knows that you want to solve it for x, and so will spit out the answers to the x-intercepts here. You might notice that I actually didn't write down the x-intercepts after I'd factored the polynomial, which is a pretty common mistake. Make sure that you do go through and list the intercepts that are required. Okay, so what you need to remember is that if a question asks you to solve a polynomial, they're looking for this. If they ask you to factor a polynomial, they're looking for this. All right, so factors, solutions. All right, keep that in mind.